Okay, so this is the answer key for tonight's homework, but first let's go over the several cases you'll see. So once you isolate the absolute value expression, if it is less than or less than equal to a positive constant, then you have an AND statement. Let's put AND right over here. It's an AND statement. So negative C is less than the absolute value expression is less than the positive C, okay? Over here we have an OR statement. When the absolute value expression is isolated and it's greater than or greater than equal to a positive constant, then you split it apart. Ax plus b is less than negative c, or ax plus b is greater than c. Now you have two special cases where if you isolate the absolute value expression and it is less than a negative constant, then there's no solution because this can never be below a negative. And the other one is where the absolute value expression is isolated and it's greater than a negative c, which is going to give you all real numbers because it will always be greater than the negative constant. All right, and then our first question on the homework I think deals with this. Let's take a look here. First question says, can you determine the solution of the absolute value of 4x minus 2 is greater than or equal to negative 6 without solving? Explain. Well, first thing we should notice is that the absolute value expression is isolated. And once it is isolated, what we're going to just look at is the C value, and we see that the C value is negative. So it pretty much falls in this case where once you isolate it, it is all real numbers. So all real numbers. And the reason why is the absolute value expression. Will always be greater than a negative constant. So this graph will always be above that negative line. All right, and then from here, I'm always going to refer back to this so you can kind of see what I'm doing. And let's talk about the AND statements because I write those separately and then I work them out. So the first one says that in the following, solve the inequality, graph the solution if possible. All right, so for the first one, it's already isolated the expression, and it's less than a positive number. So right here, absolute value expression, less than a positive number. So our final form is gonna look like this, but I'm gonna split it up into two pieces so I can work them out individually. That way, so it's easier to see me work out each one. So we can see that the absolute value expression is greater than the negative constant. So x is greater than negative 3. And this is an AND statement. So make sure you know the difference between AND and OR. Less than equal to is AND. Greater than equal to will be an OR. And x is less than the positive constant, so less than 3. And here we can see it's actually done, right? I don't actually need to do anything else. They're both isolated, and they're both set equal to some constant. So you could actually write your answer like this, and I would accept that. I'm going to keep it written in this form right here. This compound inequality, so negative c is less than x, which is less than 3. So there's my first answer there. All right, for my next one, once again, we see that the absolute value expression is isolated. And it is a greater than. So greater than, if you refer back, is going to be an OR statement. So the absolute value expression is less than the negative c. So notice that c is 3. So d plus 9 is less than negative 3, or the absolute value expression, d plus 9, is greater than positive c, so greater than 3. And now you'll see me work these out, and it'll pretty much be in the same manner. So I'm going to subtract 9 from both sides. So I do get that d is less than negative 12, or on the other side, we're going to solve it the exact same way. We're going to subtract 9 from both sides. So d is greater than negative 6, and both isolated, both solved. So this right here is going to be my final answer. D is less than negative 12, or D is greater than equal to, or D is greater than negative 6. One thing is too, you're supposed to be graphing these. So let me go back and do that real quick. Sorry about that. So for this one here, you're going to see how I do it. It's a between statement. So negative 3, positive 3. I'm just going to connect them real quick, just like that. Number line here, negative 12 is smaller, negative 6 is bigger. They are OR, so they're splitting apart. So this one goes this way, and this one goes this way. And I did it off the line just so you could see where it's going, okay? All right, let's take a look at number 4 now. It says the absolute value of 16 minus 7 minus 8 is greater than or equal to 3. So before we even start figuring out if it's a and or statement, we're going to first add this 8 value because it's not isolated, the absolute value expression. So we do come up with the absolute value of 6t minus 7 is greater than or equal to 11. And from here now we can see it's a greater than or equal to, so that's going to be an or statement. And we're going to go ahead and work this out. So you first start with 6t minus 7 is less, less than or equal to negative c, or 6t minus 7 is greater than or equal to positive c. So we have those two right there now. Now I'm going to work them out. So on this side I'm going to add 7. So I come up with 6t is less than or equal to negative 4. Divide both sides by 6. And I come up with t is less than or equal to negative 2/3. Or, and on the other side I'm going to work it out the exact same way. Add 7. So I get 6t is greater than or equal to 18. To isolate the t, we divide both sides by 6. And we come up with t is greater than or equal to 3. And there's my final answer right there. There's my or statement answer. From here, graph it. So I have a closed circle at negative 2/3 and a closed circle at positive 3. And it's an or statement, so they do split apart. So there's that one there, and there's that one there. All right, for the next one, first thing I see is I have to isolate the absolute value expression. So we're going to undo this multiply by 3 by dividing both sides by 3. So I do come up with the absolute value of 14 minus m is greater than 6. So we're going to write this in two pieces. 14 minus m is, and that's an or statement, less than negative c. Or 14 minus m is greater than positive c, which is positive 6. Okay, and once again, always refer back here. You can take a look. It was a or statement because it was greater than. All right, from here, go ahead and work this out. First thing I'm going to do is subtract 14 from both sides. So negative m is less than negative 20. The m is not isolated, so I divide both sides by negative 1. Recall that when you divide or multiply by a negative number to isolate your variable, you do flip the sign. So now this is m is greater than 20. Or, and now I work out the other side. So subtract 14. Negative m is greater than negative 8. Divide by negative 1. And the sign flips. M is less than 8. And this answer is correct right here. So let's take a look at the graph of this one. So once I graph it, number line, open circle at 8, because that's a smaller one, open circle at 20. So these may be backwards, but I can still see that m is less than 8, and m is greater than 20. Which looks like that. So it's a split. There's no shading in between. So the solution set lies on the outside, but not including 8 and 20 because there's no equal bar. All right, on to number 6 and 7. So for these, hopefully you see that before you even start working it out, you do have to isolate the absolute value expression. So first we always add or subtract. So we're going to add 13 to both sides. Negative 5 plus that is going to be 8. And then we still have to undo this multiply by 2, so we're going to divide both sides by 2. And we come up with the absolute value of 3w plus 8 is less than 4, and now it's isolated. And once again, it's this one's going to be an and statement, and because it's less than equal to, so always refer back to this. So we are going to write it as two expressions. So the first one is that the absolute value expression is greater than the negative constant. So 3w plus 8 is greater than the negative constant. This is the and statement, not the or. It's and. 3w plus 8 is less than the positive. And then we just work them out. So here we subtract 8. So we get 3w is greater than negative 12 divided by 3. Now I don't flip the sign here because I'm not dividing by a negative number. W is greater than negative 4. On the other side, we work it out the same. So we subtract 8. Then we divide by 3. So, and W is less than negative 4/3. So when I write this final answer, negative 4 is less than W, which is less than negative 4/3. Number line. Open circle at negative 4. Open circle at negative 4/3. It's an and statement, so it's going to be connected. So that's a between. All right, let's take a look at the number 7 now. Once again, we do have to isolate it. So the first thing we're going to do is we're going to take away 5 from both sides. So negative 3 absolute var 2 minus 4u is less than negative 18. Divide both sides by negative 3. So we get the absolute value of 2 minus 4u. Since we divided by a negative, we flip the sign, greater than 6. All right, so this is an or statement. So 2 minus 4u is less than negative c, or 2 minus 4u is greater than positive c. Okay, so c is 6, so negative 6, positive 6. All right, and you just work this out. So I'm going to subtract 2 from both sides to start this off with. So negative 4u is less than negative 8. Divide by negative 4. I am dividing by a negative, so the sign will switch. So u is now greater than 2 or. And we'll work out the other side. Same process. Subtract 2. Divide by negative 4. And since we're dividing by a negative number, we do flip that sign. U is less than negative 1. So in the number line, the smaller number is negative 1, open circle. And 2, open circle, is greater than, so they're splitting apart because it's an or statement. And there's your answer. Oh, sorry, there's your answer right there. All right, down to the last several problems here. All right, same process. So we're going to work out number 6 here. Isolate it first. We're going to subtract 7. So 6 absolute value of negative f plus 3 is greater than 0. Still need to isolate it, so we divide by 6. So the absolute value of negative f plus 3 is greater than 0, which is fine. 0, it can be 0. You'll see what happens here. So it is a split because it's greater than. So negative f plus 3 is less than 0 because there's no negative c. Or negative f plus 3 is greater than 0. So I'll work these out real quick. So first we subtract 3. And we divide by negative 1. And don't forget, when you divide by negative, you flip the sign. So f is greater than 3. Or, other side, we repeat the same process. Sorry about that. Divide by negative 1. And we flip the sign. So f is now less than 3. Okay, when we draw our number line, this is our answer here. So when we draw our number line, we notice that both of them have 3 with an open circle. So 3 open circle. One says that it is greater than 3, and one says that it's less than 3. So pretty much it's the whole real, it's the all real, it's the whole number line except for 3. So there's your answer right there. All right, let's take a look at number 9 now. So for number 9, it's already isolated, but it's greater than or equal to a negative number. And we talked about that in the notes, that if it's greater than is all real numbers, greater than a negative number is all real numbers, less than a negative number is no solution. So in this case here, it is greater than a negative number because this is isolated, so this is going to be all real numbers. And when I graph this, it's the whole number line. There you go. For the next one, we can see that it's the other special case. Absolute value expression is isolated. It is less than a negative number, which is not possible. So the answer here is no solution. Okay. And that, I can't graph that, so I'm not going to. So let's box this in. This is the answer here. And this was the answer here. All right, on to number 11. Number 11 says, the rules for an essay contest say that entries can have 500 words with an absolute deviation of at most 30 words. Write and solve an absolute value inequality that represents the acceptable number of words. So if you recall the formula from your notes, it's the absolute deviation equals the absolute value of x minus the given value. So we start with the absolute value of x minus, so the rules for an essay contest say the entries can have 500 words. That's the given value, 500. And we don't actually use an equal bar, we use whatever they say, with an absolute deviation of at most. At most is less than or equal to 30 words. And right here, you can see that it is a between statement, so it's an and. So we're going to say x minus 500 is greater than or equal to the negative c, so negative 30, and x minus 500 is less than or equal to the positive c, which is 30. And then we just work these out, and we write it as a compound inequality at the end, and that's going to be our solution. So we can add 500. So x is greater than or equal to, this looks like 470, and over here we add 500. X is less than or equal to 530. So for my compound inequality, smaller number, less than or equal to x, less than or equal to the bigger number. You could have also left it as the and statement, but both are acceptable.